Hi to all. Today we are going to discuss about Unit 1 Power Electronics subject, that is Power Semiconductor Devices. Power Semiconductor Devices, what are there? What are the various types of power semiconductor devices? A semiconductor in the sense comes into mind is diode. Diode is a semiconducting material, P-N junction, one junction and two terminal device, anode, cathode it consists of. What are thyristor family? What is the difference between power diode and normal diode? And what are how SCR works, how IGBT works, how MOSFET works, what are the characteristics, switching characteristics, on-state characteristics and off-state characteristics. All those will be discussed in this video. Before going to discuss about Unit 1, please subscribe and press bell icon and activate bell icon, press all, then you will get notifications. Don't miss the notifications. Actually, diodes are controlled or uncontrolled. Where which is controlled device? What are the control uncontrolled devices? Like that, if you go for SCR, MOSFET, IGBT, those are controlled devices because if you give the voltage for the gate, the SCR will be turned on. If you fall down the voltage level below the holding current, then SCR will be turned off. That means control is possible through SCR, but a diode is an uncontrolled device. Why it is called uncontrolled device? Because of that only in forward bias it acts as a closed switch. When a reverse bias it acts as open switch. What is the difference between power diode and normal diode? There are too many types of diodes out there. Power diodes having larger ratings. It has a through larger cable we have to connect. Whereas in normally general purpose diode is a small one. That is symbol of diode is anode and cathode. Diode is an uncontrolled device, whereas the SCR, MOSFET, IGBT, these are controlled devices. In the SCR, MOSFET, IGBT also, one of that SCR is a voltage control device, MOSFET is and IGBT both are current control device, because based on input currents given to MOSFET, IGBT, they will work. Since the SCR is works on principle of current voltage, whatever be the gate voltage we applied, gate pulse we applied, that's on that SCR work. Hence, the SCR comes under voltage control device. After that, a MOSFET, IGBT are current control devices, but diode is a uncontrolled device. Now let us start construction of power diodes. Power diode is basically two-terminal PN junction semiconductor device. Power diode is a basically it is a two-terminal device. Anode and cathode both will be there for power devices, that is power diode. It is also similar to normal diode or general purpose diode, but some construction point of view, additional N layer will be added in power diodes. The structure of power diode as shown in figure, depletion layer or space charge region, but an additional N layer will be added here for power diode. Additional N layer will be added. Similarly, the diode having positive terminal may be termed as anode, another one is negative terminal is maybe termed as cathode. How to remember negative terminal is a line will be drawn in the symbol, that is cathode. You all know that how the PN junction works. P region and N region, the mobility of charges in P region is electrons, and N region will be protons. Like that, diodes are the simplest devices having only two layers, two terminal and one junction. Remaining all having three junctions or two junctions, like that. So many devices are there. The ordinary signal diode have junction formed by P-type semiconductor and N-type semiconductor. P-type semiconductor and N-type semiconductor. The ordinary signal diode or normal diode have junctions formed by p-type semiconductor and n-type semiconductor. Joining the type is p-type is called anode, and other side lead joining the n-type is called cathode. The figure below depicts the structure of ordinary diode and its symbol. Power diodes have longer power voltage and current handling capacities than ordinary semiconductor diodes. The diode conducts during forward bias condition, whereas in opposes the current or voltage when it is in reverse bias condition. You can see this, what is forward bias, what is reverse bias. When positive terminal is connected to forward bias means now, when P terminal is connected to negative and N is connected to positive, now it's said to be in forward reverse bias because positive is connected to negative terminal of battery or voltage source, and similarly, and N terminal is connected to positive supply. Hence, it is in reverse bias. Depression layer between P and N junction will be increases. In reverse bias, P-type region is connected to negative voltage and N-type is connected to positive terminal as shown above. In this condition, holes in the P gets filled by electrons from the battery or cell. In other words, the holes gets the electrons in the N-type material is sucked out of the diode by the positive terminal of the battery. So diode gets depleted of charge. When depletion layer width increases, it acts as open switch. The resistance offered by the diode is very high when it is in reverse bias. Now go to what is now, when the diode is in forward bias condition, when the diode is in forward bias, the positive terminal is connected to plus of the battery or voltage source, and negative, that is cathode, is connected to negative terminal of the battery, that is in forward bias. In forward bias, P region of the diode is connected to positive terminal of the battery, where the N region is connected with negative region. During the forward bias, the following process will occur. The positive of the battery pumps more holes into the P region of the diode. The negative terminal pumps electrons into N region. The excess of charges in P and N regions will apply pressure on the depletion region. It will make it shrink. As the voltage increases, the depletion layer will become thinner and thinner. Hence, diode will offer lesser and lesser resistance. That means in forward condition, forward biased condition, the voltage acts, the diode acts as closed switch. At a particular voltage level, VF called the threshold or firing or cutoff voltage, the depression layer disappears and hence forms this point on the diode starts conducts very easily. At the particular voltage or forward voltage at which the depression layer disappears, that is అక్కడ నుంచి, from that onwards, the diode starts conducting. This is the VI characteristics of power diode. This is a current through terminal. Whenever forward condition is there, the current will increases when it is forward bias. This is the VI characteristic curves. Under reverse bias also, under reverse bias it acts as closed switch, and there is no, it won't allow the current, only voltage will appear. That is the above, that is about forward bias and reverse bias of SCR diode. But in case of power diode, what are the characteristics of power diode? Having additional N layer, N substrate is connected to power diode. In near to cathode, it is a cathode terminal. Near to cathode terminal, a additional n substrate will be added. Near to this terminal n layer, additional n layer will be added for this. Therefore, by increasing the holes in the n substrate, it acts as power diode. That is the major difference between normal diode. Normal diode having only two layers of pn, p and n. Here additional n layer will be added for power diode. Now we'll go for silicon control rectifier, that is SCR. The full form of SCR is silicon control rectifier. Why the name is given for semiconducting material, that is silicon control rectifier or semiconductor control rectifier is a 4-layer solid state current controlling device. SCRs are unidirectional device, that is that can conduct current in only one direction. That is SCR is a unidirectional device. And SCR can be controlled by using current. By if you switch off, if you want to switch off the SCR, what we have to do is reducing the holding current below the normal value. Then we can get switch off the SCR. SCRs are the unidirectional devices that can conduct current in only one direction and opposes as opposed to triac, which are triac is a bidirectional device. Current can flow through them either direction, that is two directions. SCRs can be triggered normally only by currents going into the gate opposite to triac. SCRs can be triggered normally only by currents going into the gate. If you give the current to the gate or voltage to the triggering pulse to the gate, then only SCR will be turned on. SCR is a control device, whereas diode is a uncontrolled device. Similar to triac, triac is a bidirectional switch. Triac acts as bidirectional switch. Coming to the construction of SCR, silicon control rectifier. SCR comes under thyristor family. It has 3 junctions, 3 terminal device, all SCR, MOSFET, IGBT, and GICT. So many devices are comes under thyristor family. The 3 terminal devices, so many are thyristor family. Already we discussed the thyristor family consists of what are the important devices we discussed in last video. Coming to the construction of SCR, what are the parts it has? A silicon control rectifier has a how many layers it has? 4 layers. PN, 4 layers are there. Now the junctions are J1, J2, J3 are the 3 junctions available for SCR. Remember that 3 junction, 3 terminal and 4 layer devices is SCR. The anode terminal of SCR is connected to P type of material of PN structure. What is the structure? Let us see now. Let us see the construction of SCR. The symbol of SCR, you know that similar to diode, except a gate pulse will be connected. That gate is represented by a line. The symbol of SCR is anode, cathode, and gate, similar to diode, but except a gate is connected between P terminal, and P terminal anode is connected and N terminal is cathode, and near the cathode what is the P terminal? That is, this is the P terminal. At that terminal we are connecting gate. The symbol of SCR is this is anode, cathode, gate. 3 terminals will be there. 2 transistor analogies of SCR this is. And another one is PN, 3 layer, 3 terminal and 3 junctions. How many junctions are there? How many junctions are there for this PN SCR is 1 PN and second junction and third junction. 3 junctions are available for SCR. What are where the junctions are available? You can see between these and these. This is the junction 1. This is junction 1 and junction 2 is, this is the junction 2 and junction 3. Near the cathode terminal, what is the P terminal? P junction is there. P substrate is there. For that, we are connecting gate. It is the gate terminal. Similar to diode, it is a anode, positive terminal, and cathode, it is a negative terminal. And gate is connected near the cathode like this. We can represent SCR is like also like that. We have to draw for SCR. Similar to diode, we drawn diode, and this line represent cathode, and we are connecting like this. Like this, we can write. This is the gate terminal. The thyristor is a four-layer PNPN device. Since basic semiconductor material used for is this SCR is silicon is the semiconductor material used for to manufacture this SCR. The thyristor is also designated as silicon control rectifier. It is also thyristor family. The anode, cathode, gate terminals of the thyristor device are shown in this diagram. The PN junctions are designated as L1, L2, L3 are three junctions, or J1, J2, J3 are the three junctions we can give. In the actual thyristor device, silicon is used as an intrinsic semiconductor to which proper impurities to be added. In the actual thyristor device, silicon is used as the intrinsic semiconductor to which proper impurities are added. The junctions J1, J2, and J3 are either diffused or alloyed. That is, a construction of SCR will be. Alloy means the junctions having so many metals we can, semiconducting materials we can connect. We have to handle large currents. The respective semiconductor terminals are properly brassed with the tungsten or molybdenum. The terminals will be tungsten or molybdenum plates in order to provide greater mechanical strength. This is a construction of a SCR, that is two transistor analogy of SCR. This is, and how the junctions are connected. N junction is connected. Near the cathode we connected gate terminal. That is the construction. Let us see what is the operation, that is working and characteristics of SCR. Now, modes of operation of SCR. There are three modes of operation of SCR. Similar to diode, forward bias and reverse bias are the two modes of operation of a diode, and zero bias. When there is no supply for positive terminal, negative terminal of a diode, it is a zero bias. There is no current flows through diode. Similar to that, diode, we are connecting modes of operation of SCR, silicon control rectifier, depending upon the bias given to that SCR. Now let us see what are the modes of operation for SCR. There are three modes of operation. One is forward blocking mode. Forward blocking mode, and second one is forward conduction mode and reverse blocking mode. These are the three important modes how the SCR operate. Coming to one by one, let us discuss now what are the forward blocking modes similar to forward bias. It is what is reverse blocking mode, what is forward conduction mode. It is a the three modes. Let us see now. Forward blocking mode. In this mode of operation, the anode is given a positive voltage while the cathode is given a negative voltage, keeping the gate zero potential. Remember that zero potential is applied for gate. That is under forward blocking mode. Under blocking mode, under forward blocking mode, what we have to apply is, under forward blocking mode, what we have to apply is junctions at positive anode terminal is connected to plus, and keeping the zero potential at gate terminal. The gate, remember that when there is no voltage applied to gate terminal, then the gate will be does not be turned on. does not turn on. That means under forward blocking mode, the positive voltage applied to cathode, anode is given a positive voltage, while the cathode is given a negative voltage. Cathode is a negative terminal, negative voltage we applied. For anode, positive voltage we applied, and zero potential is applied to gate, that is disconnected. Gate will be disconnected. In this case, junctions. What about junctions? Junctions J1 and J3 are forward bias, while J2 is reverse biased. The junction J2 is reverse biased. The junction J2 is reverse biased, due to which only a small leakage current exists from anode to cathode until applied voltage reaches to breakover value, at which J2 undergoes avalanche breakdown. It is known as avalanche breakdown, due to which only a small current, leakage current, exists from anode to cathode until the applied voltage reaches its breakover value. మనం పాజిటివ్ టెర్మినల్ కి ప్లస్ ఇచ్చాం, యానోడ్ కి పాజిటివ్ వోల్టేజ్ అండ్ నెగిటివ్ వోల్టేజ్ అప్లై టు cathode, but there is no gate potential, hence it will be in forward blocking mode. Under forward blocking mode, when it will be disappear at avalanche breakdown, junction J2 goes to avalanche breakdown, and this voltage is known as breakover voltage. It starts conducting, but below breakover voltage it offers very high resistance to the current. అంటే SCR below breakover voltage apply చేస్తే SCR does not conduct. It will be in off state. When junction J2, J1 and J3 are forward bias, but J2 is reverse bias, due to which only a small leakage current exists from anode to cathode until the applied voltage reaches to breakover value. J2 undergo avalanche breakdown. At this breakover voltage, it starts conducting, but below breakover voltage, it offers very high resistance. Very high resistance, it acts as open switch. This is about forward blocking mode. What we have to remember here, J1 and J3 are forward biased because we connected anode is given to positive voltage while cathode is given to negative voltage, keeping the gate is zero potential. That is zero potential in the sense it is open, gate is open circuited from the source connect, we are not connected to the source. Now go for forward conduction mode.